So by the end of this lesson, you will be able to know the difference and similarities between displacement and distance, describe in another way ratios, and also know the difference and similarities between velocity and speed, and also calculate the average velocity for a trip with multiple parts. So we look forward to today. So you rock through that. All right, so just a quick format of how this works. We went through all the factoid stuff. Now we're going to learn how to apply that. So this is what lectures look like. I post a question. What I want you to do is I want you to think about it without conversation with other people. If you happen to be a person that requires talking to learn, like you're an auditory processor type person, I need you to hold back and refrain momentarily, okay? I want this to be your guess. I don't want you to influence others or be influenced by others. I just want you to bring your best shot. After I give you some time, I'll say, okay, talk to your neighbor, talk to people around you, have a conversation about that, and then together come up with a conclusion. And I'll see if you're right. I'll summarize. That's what lecture looks like. Okay, so there's a lot of talking to people in the classroom context, trying to figure stuff out. Okay, do that. So give that one a shot without talking. Thumbs up when you have a guess. Have a conversation.
Yeah. It's also be it's probably just like the distance most likely. I think it's just always constant. Yeah. And I know it's something like that. Could be C, but
It's B or C. I don't.
Yeah.
It's definitely not D.
Yeah.
It could be E, possibly, depending on what the answer actually is.
What do you think? Correct answer is B, 40 meters. So this is true for the rest of the year. Anytime you see the word magnitude, recognize that life just got a little bit easier for you. Okay? That is the absolute value of. Okay? So we can say, what's the displacement, magnitude of displacement, what's the magnitude of velocity, what's the magnitude of the force, what's the magnitude of the magnetic field. You'll see that throughout the entire year. Okay, it's just the absolute value of that measurement. Okay, you know that? Thumbs up when you have a guess. Have a conversation.
B. I'm pretty sure. That's just because 92. Explain that 92 is the absolute value. Yeah.
Okay, correct answer is B, -30. Okay, so just a quick thing. Okay, so initially you're at 40 yards, and finally, you're at 10 yards. Good with that? So, what does the negative sign communicate? Direction. Does that make sense? Now, here's an opportunity. I'm going to try to coach you on how to take notes in this class. These questions are kind of like the playground of physics. We're applying things. We're seeing how it works and how it doesn't work. If you get one of these wrong, that is a prime opportunity for you to jot something down, because your mind just got changed. Something got updated. Something got like revised in terms of your understanding. Okay, jot something down. That's your journal entry for that question. That makes sense. Like, you don't. If you're like, I got it. I don't necessarily think you necessarily need to write stuff down, but you could. But when you get something wrong, that's capitalize on that. Okay? So each person's notes are going to look different than other people's notes, because you're kind of just giving yourself feedback for how your understanding is being updated. That makes sense? Okay. All right, so same scenario, but this is what is the distance rather than displacement. Tell your neighbor. Correct answer is A. Everybody go with that? Okay. So that's our first comparison between distance and displacement. Okay. So, so we already mentioned here, how is direction communicated? Positive, negative sign. With that. So here's a limitation of what we're studying so far. We are studying motion along a line, one dimension. So you're either going this way or this way, but you're stuck. You can't like go. You're like stuck on a line. We could also go up and down, but it's just one dimension for right now. That's going to be true for this chapter and the next. Unit 3, then we'll like break out of the line. But right now we're just stuck on the line. You're like, oof. Okay. So, the default is, like, think of a number line. The right is usually positive, to the left is usually negative. Okay. But that doesn't have to be that way. That's just kind of our default. Or up is usually positive, down is usually negative. Okay. All right. So is displacement a scalar or a vector? Vector. Because
It has a direction.
it has direction. Okay. So can distance ever be negative? No. Displacement? Yes. Which of these two measurements has more information wrapped up in it? Distance or displacement? Displacement. Guess what we're going to use in physics? Displacement. It's more information rich. Okay. up when you have a guess. Have a conversation. Correct answer is B. Okay. Our initial was 20. Final was 30. Okay. So what displacement looks at is how far you got away from where you started and in which direction. That make sense? Was the distance away from where you started and in which direction. Okay. So same scenario, but now this time is how much distance. Have a conversation. Okay. Correct answer is E. How far your feet travel. You see another distinction between distance and displacement. Okay. Correct answer is 0. 0. I'm sitting here about to throw up. I need oxygen. Like 0? What do you mean 0? Why is it 0? I didn't accomplish anything. I started where I ended up where I started. Okay. Your feet can tell you your distance. For your displacement, you just, sorry to inform you, but you ended up where you started. Get that? Yep. Thumbs up when you have a guess. That's a good question. Have a good conversation.
Because there's no construction, so the displacement go down, but then your distance will go up.
It depends on your measuring
Yeah.
distance.
It's like if you're going in a circle, if you stop.
If you measure distance and then just how far you go, like you measure distance. Oh, like, yeah. Because if you do both, you just skip.
Correct answer is D. Okay. So when you're working on the worksheet that's due on Wednesday, if the problem doesn't specify what the positive direction is, you get a pick. And my strong recommendation would be make whichever way the object is moving, make that the positive direction. So as long as the object doesn't turn around, distance and displacement are interchangeable because you made that the positive direction. Does that make sense? So you don't have to I don't know. Like if it's going in one direction, you're right. Distance, displacement. Okay. All right. So this is me just trying to train you how to take notes in this class. Typically, you're not going to get to see this. You're not going to see this slide. This should be. You should have already captured this. Okay, in your notes as we bring stuff out. Does that make sense? Do you see why I recommended printing out the slides? Like it gives a context to apply stuff. That's what makes physics tough. Is like you're not memorizing things. You're applying knowledge to different scenarios. Okay? Look at that. Okay. This next thing is just kind of a subtle detail. Clock reading versus time duration. In geometry, what are the dimensions of a point? How long is a point? Like on a number line or a coordinate plane, take a point. What's the length of that? 0. Okay, just a placeholder. Clock reading is like that. It's like a point on a number line. Okay, how long is that? It's not. It's just a moment in time. Okay, so it's a moment in time. It is a point on a timeline. Versus a time duration. What's delta stand for? Change in time or clock reading. Okay, so delta t is final clock reading minus initial clock reading. Okay, there are multiple different physics resources that you have available to you. Technically, our textbook is through OpenStax. It's a free online resource. I don't really assign, read this chapter. This is purely a reference. you can Google things as well. It's like, hey, Wikipedia, or like whatever. Okay. If you're like, oh, I've got to have a physical textbook, that's totally fine. I've got some you can check out. Okay. But they're simply references. The reason I bring this up is because some texts get lazy, in my opinion, and just write T when they meant to write delta T. Okay, this is a better, more robust way to do this. It's kind of a might seem picky, but like delta T is like for how long. This is like what moment in time to this moment in time. Okay, but just recognize that some people get lazy and they don't write the delta, and they need to write the delta. So just heads up with that. Okay. All right, we're going to look at ratios in a little different way. Okay, so you go to the gas station, fill up with 14.7 gallons of gas, costs you $58.40. We can do this problem on a calculator. That's easy. But what does that communicate? What does this mean? My suggestion would be to look at the units. How do you describe the number is this? Like when you do that on a calculator. But what is that? Okay, price per gallon. That is correct. But I'm going to push you a little bit further and say, can you explain that without using the word per?
$3.97 for every 1 gallon.
Yes. Okay. So check this out. We've got dollars on top, gallons below. This is the same thing as writing this, right? I mean, that's not taking the units, being consistent with the units. Okay. So it's $3.97 for every 1 gallon of gas. Instead of saying per, we said for every 1. You all right with that? This is what we're used to seeing on all gas station signs. Dollars per gallon. But what would happen if I flipped that? What would that ratio be? I mean, we can find an answer. That's easy. Just takes a calculator. But what is that? Tell your neighbor. Okay. In this class, units are really important. Not just in the answer, but how you are unpacking that problem. We have gallons on top, dollars on bottom. So this communicates what?
$0.252 gallons for every $1.
Yep. Which means how much gallons you can buy for every $1. Gallons per dollar. Good with that? So, in general, What does a ratio communicate? You've been doing ratios, division since what, 4th, 5th grade? I don't know when we teach division. But anytime you divide something, you're really finding a ratio of those things. In general, what is that? What are you finding? It's how much of the numerator, the top thing, you get for every 1 unit of the denominator. Okay? So this is just a different way to look at division. Anytime you're dividing, it's saying how much of the numerator, how much of the top measurement you get for every 1 unit of the bottom measurement. Good with that? So just letting you know, that's a good thing to write down. Like, that's a good takeaway. Just trying to give you some feedback there. Just big picture. Okay. Have a conversation. Okay, here's just a quick timeout thing. A lot of learning is going to take place in these conversations. If you're sitting in a place that isn't conducive for those conversations, my recommendation would be either like, well, initiate so you are, or move to a different seat so that fosters that. Make sense? You're just sitting there like, that is not a helpful strategy for success in this class. Okay? All right. Correct answer is C. Okay. You might not have needed to know anything like, well, it's miles per hour, meters per second. That seems to jive. We're good there. Here's what I want you to take away from this. And this trick works the rest of the year. Let's say you forget the unit of this. I know that's probably not going to happen for velocity, but there are other measurements coming that you're like, I don't know. You can look at the equation and figure that out. What's the unit for displacement? Meters. What's the unit for time duration? Seconds. The unit for velocity is meters over seconds. That will always work. And it's a little trick to the trade there. Thumbs up when you have a guess. Talk to you later.
Yes. Could you like away from the
It's constant. Oh, it's easy.
Correct answer is B. You move 3 meters every 1 second. Good there. Sorry, neighbor. Correct answer is B. Okay. Velocity is equal to displacement over time duration. I was given 2 positions and 1 time duration. So that's final minus initial. See where that came from? Over the time duration. So my final was 10 yards minus my initial was 40 yards over time duration of 5 seconds. So I get negative 30 divided by 5. So negative 6 meters a second. What does the negative sign communicate? Direction. So that's as far as we got with all the other classes. We got a worksheet due on Wednesday. Again, if there's assignments you need to do better on from last week, make sure that happens by tomorrow.